Hello, this is Will Timpson with CAD Craftsman. This will be a demonstration of creating and processing a platform using Steel Designer Pro. As I begin modeling this project, there are many keyboard shortcuts, shortcut windows, SOLIDWORKS features, and custom settings that I use to speed the process. This is not a SOLIDWORKS training video. I will not pause and explain features or how to access them. The viewer is expected to already possess high-level SOLIDWORKS skills. I will point out Steel Designer Pro controls. With the add-in active, the Project Command Center appears at startup. Select the Projects tab at the top of the window, select the New button. The project window wizard appears to walk you through creating your project. Project number and project name are required fields. All other fields may be added or changed later and are used to populate your drawing sheets. I will add some information here. The next page is project zone information. The left column is the zone name, which becomes part of the file name. The second column is the zone code, and the third column contains the description. You may create multiple zones when creating the project or add more later as needed. Page 3 is the project settings page. Other than project location, these may be modified later. Once the settings are adjusted to your preferences, they can be set as a default for later use. The next page allows you to assign sheet templates to your project. You can have various sheet templates that may be required by different customers. The project initial assignment is made here and of course can be changed at a later time. Drag and drop them as needed. You can drag another template over a previous one if required. Choose Drafting Standards allows you to assign different standards to different drawing types. The drafting standard can be changed later using a batch document process if needed. Choose Driving Sketch allows you to start your project with a particular driving sketch or simply a blank one. Driving sketches can be added to the project as parts later as well. Select Create to complete the process. Steel Designer Pro returns to the Project Command Center and displays the newly created project and zone. Highlight the new zone, then select the Project Specifications button. The Specifications panel is where you create and choose plate specifications. Create and save templates here as well. I will use a template that contains many of my plates. Select Use Template and then select your preferred template and the Use button. Hit Update to make sure everything sticks. Clear the panes to return to the project zone. You may now open the zone assembly from the interface. Configurations are listed to allow opening the assembly in a working or all suppressed configuration for speed. While populating the model, it is best to check the box for Disable Consolidation to pause the process until we are ready. I will select the SD Parts tab and then the Driving Sketches button. This brings up the interface which allows you to access the library. Clicking on the image directs you to the library. Select the preferred driving sketch part and the Use button. Check Insert as Envelope and Insert at Origin, then the green check to start the insertion process. Steel Designer Pro uses enveloped components for driving sketches and dummy components in connections. The envelopes allow items to be easily hidden in the modeling environment and in drawings. By selecting the SD Welded Members tab, the selection filters for beams, columns, and other members become visible. Select the Columns button, and then by clicking on the image, you are directed to the library. It is important to note here that the buttons are simply shortcuts to a particular area of the library. Within the library chooser, you may then select any filter. This section is a bit large. By clicking on the section, the flyout menu appears. The lower row contains Steel Designer Pro icons. On the left is Modify Sections. Select this to adjust the column section size through the Modify Section pane. Now we will select the SD Connections tab and the Base Connection button. Clicking on the image directs you to the library. I will choose a simple base plate connection and click Use. Select the insertion point and the welded to member component. Steel Designer Pro takes the connection from your library and places it inside the column assembly. The connection is located, processed, matching section sizes, processing cuts, and punching holes as required. A driving principle of Steel Designer Pro is that you create items only once. By updating drawings before copying the members, those updates will show in the new members, meaning less cleanup later. Now we can copy the column to the other three locations and tidy the feature tree by adding a folder. Select the SD Parts tab and then the Grids button. Clicking on the image directs you to the library. Select your preferred grid part and click Use. Grids may be placed individually, or you may select Insert on Sketch to populate all the grid lines at one time. Grid parts are envelopes with their value determined by a SOLIDWORKS file property. After using the automated numbering during the insert process, select a part in the feature tree and change the property as desired. Steel Designer Pro scans down the feature tree to look for items to process. When inserting connections and welded members, the process can be sped up by suppressing unnecessary members. Creating an all suppressed configuration allows you to open the model quickly. Creating a working configuration will speed up the insertion process. Within the working configuration, be sure to look at the advanced options and uncheck Suppress New Features and Mates. By selecting the SD Welded Members tab, we can select the Beams button to place beams on the lines of the Plan View sketch. You can choose individual lines or select Insert on Sketch to allow Steel Designer Pro to populate the floor. I will choose a single line and check Update Primary Section. I will use W12 by 26 for this perimeter beam. When changing section sizes, SOLIDWORKS sometimes adds or shows the weldment profile sketches, which can be deleted or hidden as needed. I will use SD Welded Members Copy function to add the remainder of the perimeter beams. I will use Copy to create the first interior beam member. Click on the new beam section and pause for the flyout menu to appear. In the lower left corner is the Steel Designer Pro icon for Modify Section. When activated, you can choose sections to change and then designate the required size. An additional feature allows you to match sections to the last selection chosen when changing a group. Sometimes SOLIDWORKS loses the section size reference and does not remember the location. If this happens, run the tool blankly and then run it a second time and select the correct section size. be sure to choose the profile location. We can change the interior beam to W8 by 21. Now select the copy button and the remaining interior line segments to finish populating the beams. After the beams are added, we can see that they have been automatically named and added to the feature tree as assemblies. It is important to note that within Steel Designer Pro, the direction of all sketch lines matters. Parts and members are placed in the model aligned with the direction of the sketch line. A good procedure is to draw lines from left to right and bottom to top. If you happen to have some that are angled, then choose a dominant direction. When creating erection drawings, the sketch direction determines the beam direction and mark position. Now we will begin adding connections between the beams and columns as well as beam-to-beam connections. Select the SD Connections tab and the Fin Connection button. Clicking on the image directs you to the library. I will choose a fin plate column flange to beam connection and click Use. The Insert Connection dialog then appears. Now we select the insertion point for the connection. For this fin connection, the insertion point is the sketch line representing the beam and column intersection point. Select the welded two-member components as the column. With a fin connection, we must now select the bolted one member. This tells Steel Designer Pro in which member the connection will reside and the other member that it will act upon. Clicking the green check mark at the top starts the insertion process. For connections with configurations, you can select which one you wish to insert. The connection image has been modified to let us know that the configuration shown is labeled near. Just as I draw sketches to ease the erection process, I also locate fin plates in a consistent manner. My preference is to locate the plates down and to the left as shown in the final plan drawings. This allows a simple erection note to take the place of marking contact faces of all the fin tabs. Given this connection's location, I will use the near configuration to locate the tab on the left. We can copy the connection from one end of the beam to the other and change the configuration. With the correct members shown, we can begin adding connections between the column webs and beam ends. I will use another fin connection here. This particular connection includes an additional holes component that clips the lower flange to allow the beam to drop between the columns during erection. Two holes components are included within the connection that allow for clipping the bottom flange on the same side as the plate location. For this to work properly, it must be inserted with the correct configuration selected for the automation to work. I again choose the configuration that places the plate in a consistent manner. Now insert the connection with the other configuration at the other end of the beam. Now we can choose the End Connection button and select a welded end plate connection. I will purposely select the welded and bolted one members in the wrong order. Steel Designer Pro adds the connection as inserted, wrong. Now I will use the Delete button to remove the connection. Steel Designer Pro not only removes the components and features that had been created, it also places the connection in a deleted files folder within the project folder. All deleted files are placed in this folder. At some point, you will delete something that you want back, and here's where you find it. The Zone folder contains all member folders and part files. The Deleted Files folder contains our connection. The zone folder contains the welded member folders as well as the zone level parts such as grids. Connections are placed within subfolders of their respective welded members. I will insert the connection correctly. After insertion, the connection interface appears and allows you to modify the parameters. We can copy the connection to the other beam end. I will add the column web to beam connections to each end of the remaining long beam. Since I did not choose the correct configuration, I need to change this connection. I could delete the connection and reinsert it, however, I will change the configuration and make the required edits. This will show that Steel Designer Pro is operating fully within SOLIDWORKS. Our processes are automated but can be edited as any other feature. For this connection, the applied flange cut is driven by a holes component with its suppression state controlled by the configuration. The correct holes component has now been unsuppressed, so I will edit the section cavity feature to work correctly. Hide the holes component and insert the connection on the other beam end. Now select SD Welded Members tab and the Stair button. Clicking the image displays the stair library. I will select the cranked stair with no top connections. This stair is a multiple attached model, so check the box and select the attachment sketches in the order shown. This allows Steel Designer Pro to position and attach the member to multiple attachment sketches. The interface allows for changing many of the parameters of this stair. For complex members with driving sketches that are hidden, there are times when SOLIDWORKS fails to process items correctly and faults appear. This is easily fixed by showing the driving sketches and rebuilding the model. It may take a few rebuilds. Now we can measure the overlap of the beam flanges and add grating to the platform. Select the SD Welded Members tab and then any filter button. Click the image to bring up the library chooser. The filters appear on the left, and here's where you can select grating. This is how you would select any new filters that you may create in the future. This bar grating is a multiple attached model, so check the box. When inserting welded members, you have the option to change the section size. This is only possible when the member contains a Sections 1. Steel Designer Pro alerts that no Sections 1 exists within the bar grate. The member is inserted and Steel Designer Pro does in-context edits of the attachment sketches to match them to the driving sketch lines. This matches the member and stretches or compresses it as required. Equations within the member work to suppress or unsuppress components as needed. We can use the interface to adjust for the beam flange overlaps. Select the Update button, then Exit. With complex member assemblies, SOLIDWORKS sometimes creates errors which may or may not actually exist. It is common with this grate assembly that we have to reset a faulted mate. Suppress and unsuppress is all that is required. You may have noticed that the columns are extended above the deck beams. Steel Designer Pro automates the process for inserting members and connections. This requires some rules for the construction of the model. Fin connections are usually inserted somewhere in the middle of a beam. To determine the connection orientation correctly, it must be located away from the column end. This driving sketch was created with these requirements in mind, and now I can adjust the column heights by adjusting the driving sketch. I could also have created another connection under the cap filter, which can work at the top of a column. Now I will begin to add fin connections to each of the beam-to-beam connections, selecting the configuration as required. These connections can be inserted or copied as desired. Experienced users may choose to open the connection from the library and update the number of bolts. This removes the need for the interface to appear and be changed. Now that the column heights have been adjusted, I need to adjust the two end plate connections. They are a bit too high now. By choosing a negative value for the edge spacing, we leave room for a top weld. We now turn our attention back to the stair. You can measure to see how the equations have created equal rise and run treads. By editing the zone driving sketch, we can adjust the top tread distance to get the correct run. Rebuilding the driving sketch propagates the change to the stair assembly, and through the parametric behavior of SOLIDWORKS, the updates are made. I will show one of the stair driving sketches to provide location points for connections. We can now select the SD Connections tab and Fin button for the beam to channel connections. After inserting both connections, I verify the plate positions are as desired and change configurations as required. With the stairs complete, I will measure from the columns to the stair and insert handrails. Under the SD Welded Members tab, select Handrails. We can select a top mount and insert it on the beam. This handrail contains configurations that allow selecting the end finish type. Having loops on both ends will be nice. The handrail attachment sketch is matched to the beam section attachment sketch, and the handrail is aligned with the beam. Due to the beam's orientation, the handrail is placed backwards with the toe plate to the outside. I will use the interface to adjust the center line offset and deck height parameters. Update and exit. Select the SD Tools tab and then the Reverse Mates button. Click on a section of the handrail. This will flip the handrail to beam orientation, correcting the toe plate alignment. Now, select the handrail assembly and click on the Component Interface button to adjust the handrail parameters. It may take a few tries to maneuver the handrail to the correct position. Change parameters and hit Update. With so many equations operating and sections updating, there are sometimes a few errors. Open the assembly and do a few edits to clear them if needed. After the handrail has adjusted, then we can insert another from the library or copy this one. reverse the mates, and adjust the location as required. I will insert additional handrails on the remaining beams. With the grate and handrails shown, we can clean up the base plate crashes. An in-context sketch can be created within the grate vendor items for a clearance cut for each handrail post base plate. I will edit each of the grate vendor items and add a sketch on their top plane offsetting from the plates. Here we can see what has been modeled in just over 1 hour. Columns, beams, stairs, handrails, and grating completely done with their respective drawings ready to be tidied up. I will open and pin the consolidation pane. Toggle the check off for the Disable Consolidation box and allow the process to run. The Consolidation Changes pane appears to allow you to select and process all the items which are new at this time. Components are collected and assigned marks per your preferences, and members are assigned marks as well. I will adjust both the part and member mark settings to use templates for short marks. You can create and store your mark preferences. If possible, using short marks will be easier for your fabricators. Steel Designer Pro pushes the mark to each component as a custom property and selects a drawing to act as master for those that have multiples. If for some reason a change is made to a consolidated component, Steel Designer Pro will adjust marks and choose a new master drawing as required. Selecting the SD Documents tab will allow you to select the Document Manager button. This brings up the Document Manager, which allows selecting all of the project documents. I will use the Consolidation pane to select welded members and find one with at least a few components. Select Welded Member Packs is a specialty function of the Document Manager. With the unfiltered drawings displayed, check a welded member and then hit the button. This selects all of the part drawing files that make up the BOM for the welded member. This is very useful for printing a batch of drawings after the shop has lost them. There are many ways to sort and view the files within the Document Manager. By grabbing the type header and dragging it up to the white space, the drawings are grouped and sorted. Click the arrow to expand the plate drawings to see them all. To allow rapid checking of drawings, click in the left column, hold Shift, and click a lower drawing to select a batch of drawings. Select Open Commit to process and leave the drawings open. You can quickly check the placement of dimensions and clean up details. Rebuild, save, and close each of those drawings. You can use this process to quickly check all of your drawings by opening as many as your computer allows. Steel Designer Pro goes through the process of opening each drawing file, swapping sheet templates, updating the bill of materials, updating drafting standards, and then updating the database. I can see that I have drawing sheets with an incorrect anchor point. Steel Designer Pro Bill of Materials is a general table created from the database information, not a SOLIDWORKS Bill of Materials. I will edit the anchor points and save over the project sheet templates. With the templates updated, I can open the same drawings again and do some cleanup. Since each part is assigned a mark by Steel Designer Pro, we can use linked note balloons stored in the Blocks folder for labeling parts. Under the SD Documents tab, we can select the Plate DXF button to process any or all Plate DXF files. We will select a couple of plates and hit Create. Steel Designer Pro creates a Plate DXFs folder within the project and adds a SOLIDWORKS part file and DXF file for each plate. The SOLIDWORKS file is a copy of the plate at the time of DXF creation for revision tracking. The files are automatically named using the zone, mark, thickness, grade, quantity, and revision. I will use the Consolidation pane and the Select and Consolidation icon to find a simple beam section for DSTV. Under the SD Documents tab, select the DSTV CNC Export button. The Export pane appears where you can select either plates or sections. I will select the Sections tab and section 29 that I found in the Consolidation pane. There are marking options for using part or welded member marks on the sections. I will skip over them here. Steel Designer Pro saves SOLIDWORKS part and assembly files and uses those to produce the NC1 file. Another folder is created within the project for DSTV export. All of the files are saved here with plates and sections in their own subfolders. The temp folder contains the SOLIDWORKS files that are used in the process. Using a third-party viewer, we can look at the resulting file.